Hi everyone, welcome to another PSC video. Today we are going to discuss a problem named DEP Nation robbing houses 1. Okay, so let's move to the description part. It is saying robbery is pretty common in DP Nation, and a robber is planning to rob houses along a street. Each house has a certain amount of gold stashed in it. Okay, so and the only constraint stopping you from robbing each of them is that adjacent houses have a very smart security system connected, and it will automatically alert the police if two adjacent houses were robbed on the same night. Okay, so given a list of non-negative integers representing the amount of money of each house. Okay, and we need to determine the maximum amount of money the robber can rob tonight without getting caught. Okay, so let's move to the givens first. It is saying each house have certain amount of gold stashed, and you want to rob them all. And the only condition that is stopping you is you can't rob two adjacent houses, otherwise you will be caught. Okay, it is. Let's take an array as a street to understand it better. Okay, and all of its indexes are nothing but houses or house numbers. Okay, for example, if this array A is this one, then all of its indexes are nothing but house numbers. Okay, and the items that are going to be put here are going to be the money in these houses. Okay, then with the condition given, if what houses I can rob and what I can't. Okay, so if I rob house number 0, then I can't rob 1. If I rob 1, I can't rob 2. If I rob 2, I can't rob 3, and so on. Okay, it's just showing that I can't rob two adjacent houses. Okay, so in this problem, it is asking us that while doing robbery in the given way, we need to determine the maximum amount of money the robber can rob that night. Okay, so robbing is one thing, but the aim is to maximize the amount of robbed money. Okay, so now as we only know that we can't rob two adjacent houses, but we don't know how much gold is there in each houses until we reach there. Like in the array, I know this is house number 1, 2, 3, and 4. If I rob 0, I can't rob 1. If I rob 1, I can't rob 2. Okay, but I don't know mm, what is the money kept there. Okay, what is the money kept there until I reach there. So what choice do I have? And why it matters? So it matters because we are asked to maximize the asked to maximize the robbed money. Okay, so now it becomes a matter of choice because like, let's take an example. Okay, so in the sample input, let's take a big example. Okay, we have 4 houses and the house have money 100, 1, 1 and 100. Okay, so let's write it here. Let's say n is 1. Okay, sorry, n is 4, and the array or the street we are taking have 4 houses, 0, 1, 2 and 3, and the money in the respective houses is 100, 1, 1 and 100. Okay, so let's say I am at house number 3. Okay, I am here. So the only choice and 2 options I have is either I rob that house or don't rob that house. Okay, so what my profit will become if I rob this house number 3. Okay, if I rob this house number 3, my profit will become 100 because the money kept there is 100. And where will I move? Because I can't move to 100. It is sorry, I can't move to house number 2 because it is the adjacent house. So now I will move to house number 1. Okay, or for the other choice that we have is we don't rob house number 3, so my profit by reaching 3 will become 0. And where will I move? Because I am not robbing this, so I can move here. Yes or no? Correct. So I'll move to house number 2. So basically, these choices can be represented in a choice tree diagram. Okay, which is if I am at a house number 3 now, I have 2 choices. I can rob or don't rob. So if I rob house number 3, where will I go? I will go to 3 minus 2, not 3 minus 1, because 3 minus 1 will give me just my adjacent neighbor. Okay, that I don't want to go. I will be caught otherwise. Okay, so that's why 3 minus 2, 1. If I am robbing, and if I am not robbing, then where will I move? I'll move to 3 minus 1, which is my adjacent neighbor 2. Okay, So similarly, if I'm at house number 1, if I rob, I will move to house number -1, and if I don't rob, I will move to house number 0. Similarly, all these choices are made. Okay, you can pause the video and see very patiently how these things are done. Okay, why only -2 and -1? Okay, because we don't want the adjacent neighbor. That's why if we are robbing the house, we are putting -2, and if we are not robbing, then we can just move to our adjacent neighbor. So that's our -1. Okay, so the ultimate choice diagram will become like this. It's a cleaner version. Okay, so now the question becomes how to maximize the profit, and solution to that is to get the maximum, we should calculate profit for both the choices, right or not? Like here, if we go here, we made two choices, here or here. Okay, so how would we want to maximize it? How would we know if what we got is maximum or not, unless we know both the profits, right? So and we know both about, like if we are some at this thing. Okay, path 1 and this is path number 2. So if we have profits from both the paths, then only can we move. So we can find maximum of path 1 comma maximum of part 2. Yes or not? That will be our answer. So that's why we should calculate profit for both the choices and return the maximum among them. Okay, that's why we are returning the maximum, because that's our motive, return the maximum profit. So now for that, what we can write is, if I am at house number 3, I have two choices. What is my first choice? First choice is this part, only first part. What I am doing, take money from house number 3, which is 100, plus profit from next robbed house. Okay, first choice. Second choice is this. What is that? Not robbing house number 3. Okay, not robbing house number 3. And so what will be my option? Then profit from my neighbor. Okay, so that is what I am doing here. So now if I have profits from both my options, option number 1 here and option number 2 here, so what I'm doing, I'm returning the maximum. Okay, I'm returning the maximum. So that's what I'm doing for all the choices, I mean all the houses that I reach. Okay, for house number 1 also I'm doing the same thing. Okay, 101 and this one is nothing but the money kept at the house number. Okay, respective house numbers, like at house number 2 money capital is 1, at house number 1 money capital is 1, at house number 3 money capital is 100. Okay, so and so on. So now we can see that as all the negative indexes does not exist. See here on this street, the index or house number starts from 0 only. Okay, any negative house number is not there. So negative indexes does not exist, so profit from these should be returned as 0 only. Yes or no? Though we have made a formula to reach or to avoid just my adjacent neighbor, so that I can't be caught, but according to that formula, if I reach at some unknown house number, means which does not exist, then I should just not move there, no? Or in simply terms, we can just return 0 from there. So that way our base case, means the minimum valid input. What is our input? Input is our house number. Okay, so minimum valid house number is 0 only. Okay, so our base case will become, if index or house number is less than 0, will return 0 only. Okay, that's the basic criteria for the recursion. Okay, if you're going to write the recursive code that way, this will become our base case. Okay, now that way, wherever there is a negative value or negative house index, okay, will return 0, 0, 0, 0, 0, 0, and 0 here. Now my first valid input for house number 0, what I am doing, house number 0, this is the money at house number 0, which is 100, and the neighbor after I visit house number 0 will become house number minus 2, which does not exist. So that's why profit from there is 0. So 100 plus 0 will become 100 only. And if I don't drop house number 0, then I'll move to house number minus 1, which is also invalid house. So the profit from there is also 0. And I need to return the max of this. So what is max? 100. So that's why wherever there is house number 0, it is going to return the money at house number 0, which is 100. Okay, here also 100 will be returned, and here also 100 will be returned. Okay, so similarly, same formula will be applied for other houses also. If I am house number 1, if I am robbing it, then my profit will become money at 100 plus profit from the house number minus 1, comma, if I don't drop house number 1, then profit from house number 0, which is 100. So maximum is 100. So that's why I'm returning 100 here. Same thing here for house number 1 we did. Now for house number 2 we are doing the same thing. So out of this profit 101 comma 100, what was maximum? 101. So we returned 101. Now when I'm at house number 3, the money at house number 3 is 100. Okay, the money at house number 3 is 100, and the profit I have made from the not adjacent house that I have robbed is 100. So 100 plus 100. And if I am not robbing house number 3, then the profit I have made from robbing the adjacent houses 2. House number 2 is 101. So now which is maximum? 100 plus 100 becomes 200. So 200 is maximum, and this is answer. Let's check it from the question. So for this test case, what was the output? Output was 200. See, we have got the right answer. So now we'll move to the pseudocode of this. Okay, here we have already dry run this because we have already taken one of the sample test cases. This was sample test case. Okay, so I will just directly move to the pseudocode in, because we are going because though there are 4 houses, but in terms of index it is start from 0. So that's why I am taking m equals to n minus 1, so that we can, for n equals to 4, we can go to 0, 1, 2 and 3 only. Okay, that's why I'm taking m equals to n minus 1. Now the function prototype will become resolve resolve then array, I mean the street we are taking and the number of houses we have. Okay, so the base case first, if m is less than 0, return 0, which we have already written. I mean, I have already shown you why this is the case. Okay, because any house number which is less than 0 is invalid, so that's why return 0. Okay, now there's the recursive part. What are we doing? We are calculating profit from our both the options. Sorry, from both the options. And what was my option number 1? This is my option number 1. Option number 1, and this is my option number 2. Okay, so for these both choices, I am calculating the profit 1, and this is my profit 2. After that, I am finding the max of that profit and returning that. Okay, so that is my final answer. And that's how we are getting things. Okay, I have already shown you on the in the tree diagram how we are getting this. So it is advised that you better pause the video and try run this code on your another sample test case. Okay, and now about the time complexity, it will become order of 2 to the power n. Why? As for each index or house, we have 2 choices. Okay, for each house we had 2 choices, either to drop or don't drop. Okay, that's why for n houses, my the total number of choices will become 2 to the power n, and which is our time complexity. Okay, space complexity will be order 1 only because we are not using any extra space. So now about the optimization, we can optimize this time complexity by using the memoization. Why memoization? Because I have shown you now, see here in this choice diagram, what was happening in this choice diagram, what was happening, these choices are repeating. Yes or no? Minus 1 is here, minus 1 is here, minus 1, minus 1, minus 2 is here, minus 1 is also here, 0 is here. So every houses are repeating. Okay, so that's why our time was increasing significantly. If we have a way to not repeat or recalculate the profit from those choices that we have already made. Okay, for the choices that we have already made, then we can use a memorization technique. And what memorization says, it says we should store the result if you calculated it once, so that you don't need to calculate it again. Okay, it says don't calculate again. Okay, so that's why I have taken an array called dp of same size and initially put -1 there. Okay, so m equals to n minus 1, I'm initializing this, then the same function, our base case, this is our base case. Okay, then if dp, I mean if the result that I'm going to calculate is already available there, then return that and don't calculate, otherwise calculate it. Okay, and how to calculate? By calculating profit from both the choices and return the maximum among them. Okay, that is the only solution. So this way our time complexity will become order of n, because we are not recalculating the profits. Yes or no? We are not recalculating the profits. Okay, so therefore for n houses we are calculating profits for n times only. Okay, for n times only. That's why time complexity will become big O of n. Now time complexity is order n, space complexity is order n, because an extra array of size n was used to store the results. Okay, that's why space complexity became order of n. But see, time complexity is comparatively to compared to the power n, it is significantly decreased. Yes or no? Yeah. So that's our final solution. I hope you people got to understand everything which I have just taught about. So wish you best, and we'll meet you in next video. Thank you.